Good morning, class. I hope you guys did well on Monday. I hope the worksheet wasn't too hard for you. I'm in Egypt right now, having a good time. But we're gonna get this stuff done. But before we start, I need to say, 1 and 2, I understand, I do, that it may be boring and you're not gonna pay attention. I understand. Please just bear with me, learn this stuff. I'll be done in a jiffy, and you'll get your worksheet 9.2, and you'll do the stuff that I just taught you. They're called similar triangles. Just pay attention. Javier, relax, stop talking. Everybody, pay attention. Now, 3rd and 4, oh my goodness. Wow, just listen. Don't throw stuff, don't get crazy. Don't change seats. Just listen up. You know what? If they get crazy, you step them out or get them in trouble because they're being disrespectful to you and me because I told them not to be. So you handle your business if you have to. Guys, pay attention, man. Jesus. Iron Man, we don't need you to use your powers right now. Use your powers in the brain, not from your hand. We don't need those Iron Man powers. Now, 56, oh my goodness, I know, you talk a lot. Wow. Just pay attention. Jonathan, gosh. Please do some work. Maybe just drink some RC Cola and get some energy. Fernando, Raymond, Josue, guys, stop getting up, moving around, talking. And oh my goodness, take off your headphones. Wow. Put your phones down. Who cares about your notifications right now? We're about to learn some stuff. We are about to learn some stuff that you need to know. So let's handle this. You ready? Because I'm ready. Let's go. Let's go. Alright. Similar triangles is what we're learning. Similar triangles. What does that mean exactly? Well, a similar triangle is exactly what we were talking about dilations in 9.1. There's 2 different triangles, but they're exactly the same shape. Not size, but shape. So here we have 2 triangles that are exactly the same shape, but not size. They are similar triangles. You need to learn how to write a congruency statement for similar triangles. And we used to write this with regular triangles, which look like this. So it says triangle ABC is congruent, approximately congruent to triangle DEF. Now, the similar triangles, the similar triangles are all written almost exactly the same. Now, this means they're congruent. This means, and I'm going to write the numbers around here, okay, so you know. So, ABC, now this squiggly line right there, that squiggly line means similar. So now it says triangle ABC is similar to DBE, and the triangle right there. So that means they're congruent. This means they're similar. Now, on this lesson you're about to do, they're going to ask you to write congruent sides. We all should know what congruent sides are. Now, if you don't, pay attention because this is review. Congruent sides. We know if we draw 2 triangles and label them A, B, C, D, E, F, that A and B and D and E are the same, B and C and E and F are the same, and A and C and D and F are the same. And how you write that is AB is congruent to, approximately congruent to, DE. Now, we know these are congruent, right? The same thing with the angles. If they ask you on this worksheet, don't say you don't know how to do it, because you do. Just write the angles. Now this is for the congruent sides, this is for the congruent angles. Now, what they're going to ask you on this worksheet about this triangle right here is, what sides can we figure out? We have certain numbers. Line segment D and E is 7, line segment A and D is 5, and line segment A and C is 3. Okay? And it's going to ask us which measurements can we figure out. And because you don't know, I'm going to tell you, and then you'll figure out for yourself on the assignment that you're going to get. We can figure out A and B. And we can figure out B and D. But we got to put them in proportional sides. Now when I say proportional sides, it's the same thing as congruent sides. That's why they want you to write them. It's almost the same thing. But they're proportional sides. So D and E are proportional to A and C. So line segment D and E is proportional to line segment A and C. Line segment A and D is proportional to line segment B and A. And B and C is proportional to B and E. Now, you have to use 3 of them that have a numeric value. 2 of them have to be proportional sides that have a numeric value, and at least 1 other side needs to be a numeric value. Now, we can't solve nothing here because we don't know nothing here. But because 3 of them have numeric values, we could figure out what A and B is and B and D. First, we got to write them in proportional sides. So I took the small triangle, AC, and put the proportional side underneath it, DE. Then I took the proportional side, AB. We don't know what that is. And I put it over AD. Okay? Now, after you do that, you want to fill in the line segments that have a numeric value. So AC is equal to 3. DE is equal to 7. AB is equal to, we don't know yet. It does not have a numeric value assigned to it. A and D is 5. So let's put 5 there. Now, we have replaced all the line segments that have a numeric value in their place, right? They have a numeric value assigned to them. So I replaced them. Now what we got to do is cross multiply. Now, that's not too crazy. All I did was circle A and B and 7 and 3 and 5. What happens now is I'm going to put a 7 AB is equal to 3 multiplied by 5. So 7 AB is equal to 15. Okay? Now, we want to get line segment AB by itself. So we're going to divide. And you write it right here. Hopefully you can see this. It's moving over here, and it's going to be AB is equal to, what's 15 divided by 7? Well, how many times is 7 going to 15? 2. And then we have some stuff left over, right? So, let's see, I think it's 2 point something, but let's find out. 15 divided by 7, oops, 15. It's 2.14. 2.14 is the answer. So now we found out that AB is 2.14. Now, we found this out. We know what this is. So we can figure out what B and D is, right? B and D is going to be equal to 5 plus 2.14, which is equal to 7.14. So BD is 7.14. So we know, we found out AB was 2.4. And those are your answers. AB is 2.14 and BD is 7.14. I would write this down if I were you in your notebook so you can use it on your homework. I'm going to give you a couple minutes to do that, okay? Write it down, please. Okay, so since we are still writing it down, I want to give you the pages to rip out. The pages are going to be, excuse me, 491 to 498, and those are in the small books in the beige cabinet. Small books in the beige cabinet, and the pages are 491, 491 to 498. Also, if they can't see this, just pause it, because you could pause videos. That's the magic of video. And give them some time. Now, after they're all done writing it down, I would like the middle row to get the books, and the people closest to the door, the far left side, to take them back. Please do not put them back until everybody gets the books, so they don't have to look for another book. Rip them out, and then put them in nicely. If you don't put them in nicely, they're going to be ugly. I don't want them to be ugly. Stop tearing up your books. Alright, so rip out the pages. Again, it's 491 to 498. 9.2. Okay, I hope everybody got their paper out. Look at it, it's in the front page. It's 491, okay? It says, lookalikes. I would use the projector. I was trying to do this on the projector, but it's so blurry and ugly that this is way better. And I apologize if you can't see that well. I'll try to write better, and maybe you guys can zoom in or something, I don't know. But do your best, pay attention. I'll say the numbers, you have the paper in front of you, just follow along. It says look-alike similar triangles, okay? So, turn the page, and first question already asks us, use the figures shown to answer each question. Now, on top of that, it says similar triangles, and it tells you a definition of similar triangles. Alright? Similar triangles are triangles that have the same shape. Exactly what I said. Now, the triangle in front of you, this one right here, is two triangles that are dilated. And they are similar triangles because they have this written. Again, that little dash right there, that little dash means that's a dilated one, okay? Identify the congruent corresponding sides. Identify the congruent corresponding sides. I just did that for you like 5-10 minutes ago. So write them down. I'll give you a few minutes for that. Also, we just did proportional sides. If you wrote down the notes, you know exactly what proportional sides are. But if you did not, let's do it one more time. Oops. Alright, so we have both triangles. And now we want to write, if you wrote similarity, this is the C, this is the similarity congruency statement. And now, which side is proportional? If these have dashes on them, we're going to put the dilated ones on top, and we'll put the regular ones on bottom, okay? Now, the original ones. So, B dash A dash over B dash A is equal to AC A dash C dash over AC is equal to B dash C dash, or apostrophe, whatever you want to call it, BC. Now, B apostrophe A apostrophe is over B and A, and it's done on all of them. So BA over BA, but the top one is the one with the dilated one. Now, these are proportional sides, and it's telling you that BA over BA is equal to the dilated BAC over AC is equal to the dilated BC over the regular original BC. Okay? Write those down. That is the question 2B. That is the question. That's the answer. Question. That is the answer to B on page 492. Write it down if you want the answer. Now, on to given triangle. This is page 493. I just turned the page. Given triangle TRP is similar, because the little squiggly line right in the middle, this one right here, on page 493 again. Triangle TRP is similar to triangle WMY. Identify the congruent corresponding sides. And we know how to do that, so you can write that on your own. So, on question 2A, they want you to write corresponding sides. On question 2B, they want you to write ratios to identify the proportional sides. So just write these on 2B using what they give you on number 2. And on 3, they just want you to write a similarity triangle congruency theorem. So just write it like this. After you are done, you're going to get what I just showed you, how to find the sides. We're going to do this one together because I think it would help you. And after that, I'm going to let you loose and do it by yourself. Okay? Alright. Similar triangles. Let's go to page 494. Number 1. And it says, given triangle ZAP is similar to triangle EDP. So write that on your paper. You don't have to write that down. It's already there. It says 1, given triangle ZAP is similar to triangle EDP. Alright, this is question 1. written out exactly what you have on your paper. Question 1a asks us, what other measurements can you determine? Explain how you know. Remember when I told you we have to have two sides of one proportional side. So two sides that have numeric values of one proportional side. There it is. And we have to at least have one numeric value on another proportional side. So that's what we got. And so we have nothing here, so we can't determine nothing here. But we do have 5 centimeters here. Alright. We can figure out ZE, put this on A. A. You can determine ZE and once again, we know what PZ is, so we're going to find out what ZE is and find out what P is. P and E. Because after we find out what ZE is, we are going to add the 5 to it and find out what the whole line segment is, okay? So we are going to put it in proportional sides. Okay, now we are going to do our proportional sides. I have just written them down for you. So we know ZA is proportional to ED. And so I put it there. And they both have numeric values. I put PZ because it has a numeric value, and we need to find what PE is, so I put it right there. Now we're going to replace them with numeric values. ZA is 4, so I'm going to put 4. ED is 12, so I'm going to put 12. PZ is 5. So I'm going to put 5, but we don't know what PE is, so we're going to keep that there. A lot of you guys don't know what P is. Anyways, we got ZA over ED is equal to PZ over PE. Now, I just replaced the numbers. The letters with the numerical value that they're equal to. That was 4, that was 12. So I replaced them. PZ was 5, and PE is right there. Now I'm going to cross multiply. Okay? And I get 4 PE equals 12 multiplied by 5. 4 PE equals 60. Now, how do we get the variable by itself? We divide. I'm going to move this over here so you can see it better. So now we got PE is equal to 15. Okay, so 60 divided by 4 is 15. Now what happened was here is I basically put the proportional sides. ZA is proportional to E and D. So I put it there. Which is equal to PZ and PE. And then I replaced them with their numeric values. 4, 12 is equal to PZ, which is 5, and then we don't know what PE is. Cross multiply. We got 4 PE and 12 times 5. 4 PE equals 60 because 12 times 5 is 60. We divided 4 because we got to get the variable PE by itself. And then we got 60 divided by 4, which is equals to 15. PE equals 15. Now, we know that this whole thing is 15. Bear with me, we're almost done, and then you'll be by yourself. Then you'll be doing your own stuff, alright? And then you won't have to hear my voice for at least a couple of days. So, we know the whole thing is 15, right? So what is ZE? Well, if we want to find out ZE and we know PZ is 5, all we got to do is subtract. So PE minus PZ, PE is 15, and PZ is 5. I hope you can see this. So PE is 15 minus PZ, which is 5. You get 10. So this becomes ZE ends up being 10. So ZE is equal to 10, and PE is equal to 15. And those are your answers for question 1 on page 494. Now, have at the rest of them. Try your best. And have a fabulous day. Go do some work. Hold on to this paper. Don't throw it away. Don't say you lost it. Don't say it got wet. Don't say you forgot it. When I come back, I'm going to be expecting these papers. So hold on to them. Or you're not going to be holding on to the grade that you have. Alright, like I said, hey, be good. Have a great day, and I'll see you when I see you. Adios. Guys, don't get crazy in here, please. Keep the classroom clean. Don't be jerks. Be good people. I'll be back sooner than you believe. And you can count on that. And if you are going to act crazy, I got one thing to tell you.